So this is a little bit weird thing here, right? Import, yeah. Import meaning that we want to import some library that somebody built already out there. So for example, do you guys know who built this line of script syntax? I have no idea, but I'm sure the Magnet company, one of the developers developed their own library, right? And then you automatically import in the Python environment. And Python, the math is sort of the inbuilt Python library, so that by simply typing like import line of script as rs, meaning that using rs that we can access all the functionality that the developer create already in the Magnet company, for example. Okay, let's say if I do like math, there's a cosine, sine, tangent, power, whatever function that you need to utilize to process the mathematical equation. There's a package. So here, and also this is a definition, right? That we learned definition. What is definition yesterday, right? So just forget about this complex the equation. The most important thing to understand the function is that what is input, yeah, and what is output. That's it, yeah. So just forget about this function here. We create the point list, empty list, okay, and then we get the latitude and longitude. One thing for sure is that the length of these two arrays must be same. This is actually really important for the software engineer. So because we create a pipeline and then the same for loop create the identical the data structure with the different information, right? But for sure, the length of the data gonna be the same. So that's why I only use the latitude. It's okay, you can use the long here, capital L or N, because we need to match this the character and with this character, yeah. And then what it does is basically in given the length of the data, we need to make a for loop. In this case, 1819 loop happening. And then we dump latitude, longitude data to the Makita projection function, and then it gives us some return value. Yeah. I mean, the projection is a little bit important thing. So I think that there's a different types of definition of a projection for the machine learning or data scientists or cartographers. But for the mapping wise, the projection is more about coordinate system. Yeah. So now we are relying on the Cartesian coordinate system, right? This is the Cartesian coordinate system. Where's my give me point? Okay. Yeah, this is point, right? This is X and Y and Z. Yeah, this is the coordinate system. Yeah, but based on the different coordinate system, even if we have a same X and Y, the final visual representation gonna be different. Let me show you something to you guys. So this is the projection. Actually, I have been built multiple projection, but it has something to do with my the work in Esri, which is a confidential project. So I couldn't expose this kind of information to you guys, but at least we know what the projection is, right? So for example, this is my number, right? Okay, click. This is my number, yeah, longitude, latitude. With the projection, probably LA is around here, right? So in the screen position, this is X and X, right? Sorry, this is X and Y. So in the camera graphics, let's say, yeah, let me narrow down, like a web graphics, this is always 0, 0, x, y. And then you increase x here. Let's say 300 pixels for along x-axis. This is the 200 pixels along y-axis. Correct. This is the 300x and the 200y, right? So there's a 3 different number. Yeah, I mean, this is a little bit confused, but bear with me. The 3 different number. The first one is the latitude and longitude. That is actually really important information. Yeah, and then we need to project this information with given the coordinate system. Yeah, so for example, if I put this number point here, yeah, maybe there's a, okay, let's say I can make a new point, 10 by 5 by 3. Yeah. Sorry. Point 10 to 1. Yeah. Where's my point? Am I wrong? Okay. Just click the point. Edit. And then if I select, and then simply looking at the property panel here. Okay. Here. Okay. So actually, you know what? This point is representing by this coordinate system, the Cartesian coordinate system. This is the x and y and z things. So again, we have a latitude and longitude, and then throughout the projection, we get the result in that coordinate system. For example, let's say in this, just try to think about like the LA here, right? The LA position is always different based on this coordinate system, right? And as a last step, we need to convert the other way, the projected position to the screen position. Actually, you don't need to worry about it. I already reserved for our project, but I'm just describe what happened behind the scene, okay? And then this LA here, this is the X, let's say 100 along the x-axis, and then maybe 50 along the y-axis. There's 3 different coordinate systems, actually. Yeah, I mean, yeah, you guys don't need to understand for now, but I'm just describing what the projection, okay? So we have a latitude and longitude projection. There is a Mercator projection. The Mercator projection is one of the famous projection here. Actually, we have a Mercator projection here. There should be. Really? Okay. Mercator projection is one of the famous and very you guys get familiar with this map, right? So can you see the like a white line? Yeah, I mean along the x-axis, let's say longitude-wise, is always even. Yeah, but look at the y-axis called latitude. The resolution is different, right? So if you go to each polar area, and then the size of the rectangle is become like elongate, right? Because this is a characteristic of the Mercator projection. Yeah. So in this case, we can preserve the angle. Yeah. However, we give up to preserve the area. So what I'm trying to say is that each projection has their own purpose. What is the sort of I mean, let's say okay. Where is this is the yeah, this is different types of the projection, and then as I said, it has a pros and cons. Yeah, let's say pros and cons. So sometimes you need to give up something in order to emphasize something. So for example, you are the captain in a ship, right? So you always want to looking at the shortest path. Maybe in this case, you don't need to worry about like the area. I'm always focusing on the angle that I need to go directly. Yeah. So in this case, what kind of projection is better? I mean, it depends on what kind of data you want to visualize on the screen. Okay. Maybe I'm too much deep, but yeah, that's fine. Are you okay?
Yeah.
I mean, yeah. It's just yeah. I mean, it's a really important concept for the visualization, particularly for the geographical visualization or urban design. Anyhow, so market projection is a, we do not need to understand. I just implement this sort of the mathematics. You guys can feel free to use for your purpose. But this is the equation to compute the market projection. So latitude, longitude, and then give us the projection, and then using the RS. RS, as I said, this is a library developed by developer in the memory company. So RS dot at the point. This is another workshop for the Rhino script, so I'm not going to talk about that one briefly, but what I'm saying is that this input is X, Y, Z, and then it gives us point. Just like point, this point, like a GUI point, yeah? And then I append this point to the point PTF array, yeah? And then I export this point to here. So now, eventually, we get this point, but there's nothing, right? Don't be panicked. So just click it, click the right button, and then click the zoom. And then we can zoom to that number. Because as I said, the catenary coordinate system, we are starting from 0, 0, 0, right? But usually the geographical position for the GPS is along the x-axis is like minus 108, right? And the plus 108. And then along the latitude, and we have a plus 90 and then minus 90. So this is all about the representing the globe. This is the sort of a promise, like a convention we need to follow. So in this case, this position is a little bit weird of the Cartesian coordinate system, but it's not important for now. So what I'm trying to say is that we have the CSV data, we expose this data, decompose this data, and then get the latitude and longitude, and then we can convert this, not convert, we can create the point out of these two numbers, and then we can see, right? So I don't know how you guys utilize the building footprint or whatever. So maybe in this case, personally, I recommend you guys to go to OpenStreetMap. Yeah, OpenStreetMap is it's very it's good sort of open GIS program. So you can just extract some particular boundary by drag a rectangle, and then we can give us some CAD file, like building footprint or highway, freeway. I don't know. There's a lot of like sort of parameters, but at least we are able to get some boundary condition of the city, and then we can overlay on top of this data. This is one way of doing this. And then this is we visualizing a simple point here. Actually, this is not that fancy. This one, this is only just point. Yeah. So this is we visualizing the position data just for now. And then I'm not going to describe it deeply because they're very similar. Also, we have very limited time. So this is what it does is based on the index. Based on the index, I really want to maximize the windows, but okay. So based on the given index number, the same operation going to be executed. Okay. So here, the same index. Yeah, as I said, the index number is really important. They are same, right? But think about this is zero base, as I said. Yeah. So they are basically the same number. So we can play out with this. Let's say index number 4, number 7, right? In this case, number 7 stands for something emission, I guess. Yeah. And then the other dimension, the 12. What is 12? Reported or not? But this is binary information, so I'm not going to use this information. Maybe other information. It's numeric information here. So this is like a histogram. This is not about like a data intensive course. So I'm not going to talk about like a medium and Gaussian things and how we dealing with outlier data, things like that. We are just wanted to focusing on the data visualization things. So if you guys are interested in just the search like the data pre-processing things, anyhow. So I use 2 more dimensions on top of the position. So one dimension is gonna be visualize the radius of the circle. Yeah, and the other dimension is going to be used for color. Yeah, So the result looks like that. Yeah. And then also you can resize the size. Yeah. I mean, the all freedom depends on your sort of the strategy to visualize. As I said, visualization is not something, convert to numeric numbers from the visual language. It's more about like a linear where extract some meaning. So in this case, human experience with insight in your domain is really, become important. Yeah. So I don't know. Because I'm just use the indexing quickly. So we need to visualize in the data like a median, average, and then an outlier. And based on that one, so we can make the other sort of a normalization techniques can be applied.
Andrew.
Yep.
Sorry. Is there a particular component that you enable preview for or something? Because I'm not seeing the points on the Rhino canvas.
Canvas here.
Yeah, so I'm not seeing these points on my canvas. Is there a particular component that you disabled the preview or something?
Oh, I see. Okay. So here's
maybe zoom out super far. It's pretty far away from X and Y 0.
Okay, so I think there's a two way. Yeah. So maybe if the camera position is toward the 0.0, 0.0. Could you?
Oh yeah, is at the origin.
Yeah, and also the other way around is that I usually select all the components and then click right button. Click right button on top of the component is a preview option. So if you have like a light gray, it is activate for preview, and then dark gray, they are deactivate for preview. So in this case, I can select this the draw only draw preview geometry. If you click it, whenever you click the component, if they have a data to visualize, they already visualize. The reason I cannot see is because I need to zoom in. So I select this component and click right button, and then press the zoom here, and it jumps to that geometry, right? So if I select this one, I can see. If I select this component, I can only visualizing point because this component is just as an output, it just gives us points. Yeah. So as a result, I'm going to turn off this one and then select all the component, click the right button, and then I'm gonna turn on preview, and then, I'm gonna turn off all the preview. Yeah. And then I want to only turn on this circle and this color. Let's see, actually, circle. I don't need this one. Yeah, this color. Because this color has the circle, which has a different size. So now I am able to see the circle, different color. It has like 3 different dimensions, right? The first dimension is the, let's say, position. And the second dimension is the color. The third dimension is about the radius of the circle. Does it make sense? So I highly recommend you guys play with and then understanding what the component does, just for fun, yeah. So we have very limited time. I'm sorry. Let's jump to other example. Let's say, let me check. Actually.